How are we doing, everyone? Okay, so this is chapter 1 of the Visual Basic book that we'll be going through this year. Let me move my little screen here so you guys can see everything. We'll talk about in the future, if you want to continue looking at my face on these videos, we'll be doing chapter walkthroughs where I do some coding where it might not make sense to have my face up in the screen. But if you guys want to look at me, let me know and I'll keep it on there. So this is a pretty typical first chapter in any programming book. We're going to be talking a lot about terminology, which is important because you want to be using the right terminology when you're going on interviews. Talk a little bit about input-output operations, logical operations, and kind of some of the background stuff that makes up Visual Basic and all programming languages. So after this first chapter, we're going to go through terminology and do some kind of vocabulary type questions as an assignment. We'll go right into programming in the subsequent chapters and not look back. So this is just going to be a little boring just for this first week, for this first chapter, and then we'll get on to some more exciting stuff. Let's see if I can get my, there we go. So objectives. For this chapter, we want to really understand what software and computer programs are. Pretty basic stuff. You guys should know that you're in programming. We'll talk about the role of you as a developer in creating programs, apps, websites, database applications. We're going to talk about the use of graphical user interfaces or GUIs. One of the new terms that developers are using now is the user experience or UX UI. That's kind of a big thing. And talk a little bit about event-driven programs. So an event is a button click or something like that, and you put your code behind it in programs like VB. We'll talk about input processing and output. That's what most of our applications are going to do that we build this year. And we'll talk a little bit about logical operations. We're going to talk about using a database. Just about every application I have built in my professional career has used a database. Think about real-world applications, X2, any application like that. You log in, click that login button. What's it doing? What's it doing in the background? There's some code back there, and it's going in, inquiring a database, and bringing up your information. So a lot of introductory programming courses don't get into database stuff, but we are going to get into working with databases because I think that's something that you will all do someday, whether you're a programmer or not a programmer. We'll identify the use of computer programming language in general, and VB in particular. We'll talk about the difference between Visual Studio and Visual Basic, and why there's a difference there. We'll talk about some of the other programming languages that are available in Visual Studio. We'll talk about what the .NET framework is. We're going to talk about rapid application development, or RAD. We're going to get a little bit into what classes and objects are, and class libraries, how they can help you as a programmer. We'll talk about ADO.NET, ASP.NET, MSIL, and CLR. Those are ADO.NET is some libraries that Visual Studio provides to access databases. ASP.NET will allow you to make web applications, and MSIL and CLR are just what happens when you compile your applications. And we'll talk about the specific types of Visual Basic 2017 applications that you can create. So let's get into this. The set of instructions that directs a computer to perform tasks is called computer software, computer program, also called an app if it's on your phone. And most of the programs we developed this year are going to be very small apps. They're going to do something very simple. Calculate payroll. You're going to enter an hourly wage and a number of hours. Click calculate, and it's going to calculate how much you make a week and gross pay, and then it'll take out taxes and come up with a final application. Basic stuff like that is what we're going to get through in this chapter. All of your applications you develop are going to live on a computer, so you have to understand a little bit about computer hardware. Examples of computer hardware are in the slide. You've got your computers, your scanners, your printers. Some of them are input devices, some of them are output devices. Ultimately, where you want your program to live, that's going to dictate what type of programming language you use to write that program. So the basic function of many programs is to accept some form of data, input data, manipulate the data in some manner, processing, and create some form of data that is usable by people or other computers, output data. So in order for the computer to execute the program and data must be placed in the computer's RAM. That's why we want all our computers to have a lot of RAM, so they'll be faster. Because when you run that program, or when you're programming, you're compiling a program, everything comes from the hard drive and it loads into RAM. So having a lot of RAM is important. The computer CPU can access the program instructions and the data in RAM to perform activities as directed by the program. So the CPU is what's going to cause that application to run fast or slow if you have a slow CPU. Saving and storing data refers to placing the data or software electronically on a storage medium such as a hard disk, a USB drive, or now we're putting a lot of our applications and data on in the cloud. So whether that be on Google Drive or Microsoft's cloud, and even our programs now are starting to be compiled and living out in the cloud. If you think about applications like AWS, Amazon Web Services. Think about Amazon, they make a lot of money. They make more money with their Amazon Web Services, people hosting their applications on Amazon than they do selling. Most people don't know that, but they make more money with Amazon Web Services than they do selling products, which is kind of crazy. Persistent data remains available even after the computer power is turned off. So this is the data that is sitting on your hard drive, not sitting in RAM. So just a little example of what a very basic computer program will look like. This is going to be your code, what it looks like in Visual Basic. Pretty basic stuff. Computer program is designed developed by people known as computer programmers or developers or engineers or analysts. There's lots of different terms depending on where you work, what they're going to call you. I've worked at many different companies and I've been called, had many different titles at those companies. Sometimes I'm just called a programmer, sometimes I'll be called a software engineer, sometimes a software analyst, I've been called a software consultant. It all depends on what the company decides to call their employees. Developers or software engineers are people skilled in designing computer programs and creating them using programming languages. Applications may consist of several programs working together to solve a problem. Developers create the program by writing its code using a programming language. So there's many different programming languages. What that program is going to do and where it's going to live is going to dictate what programming language you're going to use. So we have Python, we have Visual Basic and C#, and we have Java. They all have their advantages and disadvantages. And being more experienced when you go into a company, I've been to companies and they've told me they want to use a particular language, and I know it's not the best language to use to write in that situation. And a good developer will be able to explain why you might not want to use one language over another. And we'll talk a lot more about that later this year. We're going to be focusing on Visual Basic and C# and maybe a little Python this year. Next year, when you have Mr. Voges, you'll be learning Java. So we won't get into Java much this year. So most VB 2007 programs are event-driven programs that communicate with the user through a GUI, graphical user interface. The GUI usually consists of a window containing a variety of objects. Event means that the user has initiated an action that causes the program to form a type of processing and result to that action. So an event would be clicking a button, clicking on a drop-down, typing something into a text box. Those are all events. So when you're in Visual Studio or Visual Basic and you double-click on that button when you're in development mode, it's going to pop up a code window so you can put some code behind there and put some code behind that event. That's what programming basically is. So for example, a user might enter data into the program and then click a button. So this is a bank application. You type in your account number, you click display bank balance, the application in theory goes out somewhere to a database, I would expect, does a query based on your account number and brings back your account balance for you. So you've got the input operation, you entering that account number and clicking display bank balance, the processing, the program goes out and does something, goes to a database or to a file, and then the output displays that account balance on that line. So that's basically what a lot of the programs we're going to be doing this year are going to do. So they're just kind of explaining what I just explained here: input, processing, and output operations. As with input operations, the variety of devices can present output. In addition to computer monitors, common output devices include printers, gaming consoles, screens, and smartphone screens. So yeah, you can output your data to a screen, to a printer, many different types of devices. Many programs with arithmetic operations, addition, subtraction, multiplication, division, are performed on numerical data to boost useful output. So most of the programs we are going to work with this year are going to do some math, simple math. Like I would say probably not more than junior high level math. So you should know how to calculate an average. You should know how to take a percentage. So if I said something cost $100 and it was 15% tax, you should be able to do the math to calculate what 15% tax is and show up a final balance. That's the kind of math we're going to be doing this year. Some of the programs that I'm going to have you write are going to use more complicated formulas, but I will give you those formulas and you'll just have to convert them into code, which isn't really that hard when we get into it. Computers, through the use of programs, can compare numbers, letters of the alphabet, and special characters. The program can perform one processing task if the tested condition is true. So logic is just two values are equal, if one number is greater than the other or less than the other, basic logic operations. And we'll do a lot of that with our programs this year. When you develop and write a program, the code you write and other features such as the GUI must be saved on the disk. When you want the program to run, you can have the program loaded into RAM and executed. The program you write, however, also can save data. Banking applications must save account data. In most cases, data is stored in a database. Collection of data organized in a manner that allows access, retrieval, and use of the data. So the basic database we're going to use this year, and we're going to do some separate curriculum on it using Access. Access is a very simple Microsoft-based, not enterprise level, it's a local database. Hopefully, depending on how this year goes, later on we will get into some more enterprise level databases like SQL Server. So that's my plan, but we'll have to see how the year goes. But I can't reiterate enough how important I think databases are. You will be working with them quite a bit in your career. So each program statement causes the computer to perform one or more operations. The developer must follow the syntax or programming use of the programming language precisely. So in programming, spelling is important. The good thing about VB and Visual Studio is there are a lot of tools to help you with how to spell things. If you VB compared to other programming languages like Python and C# is not case sensitive. So you can write a variable name in all uppercase, or you can write it in all lowercase. It means the same thing. Some programming languages are case sensitive, so you have to be very, very careful about cases. I've seen people chase their tail for hours and hours because they forgot a capitalization. So with VB, you don't worry about that as much. And that's why VB is a nice introductory programming language, because you're not going to spend as much time spinning your wheels with syntax type issues. And I've seen all these programs so many times. Usually when you're having a problem, I can go over, look at your program, and within 3 seconds figure out what's wrong and fix it for you. Sometimes I'll let you suffer a little bit if I think it's something you should find, but usually I know right away what's going on. Most developers use a tool called Visual Studio 2017 to write Visual Basic programs. So Visual Studio is the IDE, or Integrated Development Environment. So Visual Studio is the program you're going to use to write your programs. Visual Basic is the programming language you're going to be using inside Visual Studio. So another programming language you could use inside Visual Studio is C#. Okay, so some of you, if you get done your Visual Basic programs quickly, I will suggest that you rewrite a couple of those programs in C#, just so you can see the difference between the two languages. So that's kind of one of the important things, understanding the difference between Visual Studio, which is your IDE, the program you're going to open to write your programs, and Visual Basic, which is the programming language. Okay, key terminology to learn with this chapter. So your IDE provides services and tools that enable a developer to code, test, and implement single programs, sometimes a series of programs. The Visual Studio IDE is very, very good. It's probably one of the best IDEs out there. Better than the Java IDEs, better than a lot of the other IDEs. It's got a lot of great tools. It's going to make it easy for you to learn your first programming language. So some examples of more programming statements here that we'll get into later. Microsoft, this is kind of a weird slide that they just threw in there. Microsoft's Imagine is something that Microsoft provides to students where they offer free software. So there's a version of Visual Studio called Visual Studio Community that you can download for free as a student. And it's available if you log on to Microsoft Imagine. So you can just Google that if you want. I think you guys are all getting laptops by the time I see you guys. We'll know for sure. So you shouldn't have to install any software, but if you have another PC at home or something like that and you want Visual Studio on there, you can download it through Microsoft Imagine. Okay, so this is what your Visual Studio IDE is going to look like. Okay, so we have a couple areas here. This is your main work area. Okay, this is where you're going to be kind of designing your forms. Okay, we have our toolbox here, standard Windows toolbar and menu bar. Okay, we have our Solution Explorer. So this is where we call this a form, a Windows form, obviously. And all your Windows forms, if you have multiple forms in your application, will be displayed here. This is where you name them. So in Visual Studio, we have a solution, a project, and a solution can have multiple projects, and then your projects have your forms. So this is, if you look at this, we see a form 1. This would be your form 1 that you see here. Then within Visual Studio, you have a properties window. So if I were to click on this button here, the properties window here would change and show me all the properties of the button. And the text box is going to have different properties than a button. So the options that you would see here would change depending on what you click on. Okay, so that's basically the IDE. These next couple slides just kind of talk about what I talked about. Some of the programming languages that are available within Visual Studio. VB, which is what we're going to focus most of our time on. Programming language that allows developers to easily build complex Windows and web programs, as well as other software tools, and it's based on the basic language. So nice, easy language to learn. Visual C++, you can make C++ applications, and Visual Studio. We won't do that this year, but some of you may create some programs in Visual C Sharp. C Sharp is a synthesis of the elegance and syntax of C++ with many of the productivity benefits enjoyed in VB. So C Sharp is kind of a combination of VB and C++. C++ is considered to be a very difficult programming language to learn. So C Sharp is somewhere between there. And I think quite a few of you will probably get at least some exposure to C Sharp this year. You can also use Visual Studio to program in JavaScript, and there's another programming language that I've never actually used myself called F#, which is for math-intensive and statistical applications. So they use that if you're doing anything like crazy math-intensive, which we won't get into it all this year. So another kind of key important thing to understand is the .NET framework. So .NET technologies and products are designed to work together to allow businesses to connect information, people, systems, and devices through software. The .NET framework provides tools and processes developers can use to produce and run programs. The most recent version of the .NET framework is 4.6.2. So when you create your VB programs, you're going to compile them. In the background, it's going to create an executable file, a file with an extension.exe. So that is a runnable program. In order for that program to run on any computer, that computer has to have the .NET framework installed. So if you take your exe that you've created and bring it to a computer, and that computer does not have the .NET framework installed, the program will not run. And all the .NET framework is a bunch of files, DLL files, and libraries that allow that program to run inside your computer. It's a pretty big thing. And you probably, if you've installed any software on a home computer, have had to install the .NET framework. Any program developed by Microsoft applications runs on the .NET framework. So you've probably seen it. You probably didn't really know what it is. It just said we need to install a .NET framework, and you said okay, and click, click, click. But it has to be on the computer. And most computers probably have it on there. So a class is a named group of program called, a named group of program code. A button is an example of a class. A class library stores the class and makes the class available to all developers that need to use it. So the nice thing about when we talk about classes and objects, we're talking about object-oriented programming, which again we'll get into later. But the nice thing about classes is if you write something and it's something that someone else in your company might be able to use, you can put it in a class and share it out there so that that person that's doing something similar doesn't have to reinvent the wheel and write the same code that you wrote. Company I worked at, we had a shared library of classes that we would write and store stuff in there. So if I was writing something, I would wonder, maybe someone in my company wrote something like this. I would go in and look at the documentation. I might be able to find something similar that someone wrote and I could use it. Saves you time. It's really nice. So a button is created from a class called an object, or sometimes an instance of a class. The process of creating a button object from the button class is called instantiation. Now, we talked about this, but this is all kind of initially going to happen for you. So when you drag a button onto your program, it's going to create a class for you. If you were creating a program in Java, for instance, you would have to write all the code for that. That's the nice thing about VB. It's going to create a lot of the code for you, so you just have to worry about the logic and the syntax. And that kind of leads me into rapid application development, or RAD, refers to the process of using pre-built classes to make application development faster, easier, and more reliable. Typically, in my career, I did both Java and VB programs, and a little bit of C#. If I was working at a client and they wanted me to develop something in Java versus VB, my quote for the Java program was usually 2 times as much as a VB program, because it's just that much more code to write. So if I'm writing a VB program and I want to put a button on the screen, I just drag it on. If I am doing that same thing in Java, I'm probably going to write 30 lines of code to put that button on the screen. I have to write the code for the button. I have to tell them the size of the button, the color of the button, how big it is. And all that is lines of code. So VB just makes that type of thing easier for you. ADO.NET provides a functionality for a program to perform 4 primary tasks when working with a database: getting data, examining data, editing data, and updating data. It's also deleting data, but they didn't put it in here. So when you're working with a program and you need to connect to a database, there are ADO.NET controls that you drag onto your screen, you point it to your database, and the functionality kind of lives in there that allows you to manipulate that data inside the database. It's a little more complicated than that, but we will get into that quite a bit later this year. We also have ASP.NET. This allows you as a developer to use Visual Studio to build powerful and sophisticated web applications. Using ASP.NET classes, programs can create websites to perform any function available in the web. ASP.NET is designed for cloud technologies and server-side applications. So when you think about creating a website, you think about HTML and CSS. Kind of a lot to type, especially if you're writing. Think about writing something like X2. That's a web application, right? So it's ultimately written in HTML. Think about the HTML that lives behind that. I don't think anyone created that application using raw HTML. They used something like Java or ASP.NET to do it. So when you're working with ASP.NET, rather than writing the HTML and CSS, you're just clicking and dragging a text box or a button over it, and all that HTML and CSS is written for you. You don't have to write it. So it makes things a lot faster. So we're going to start talking a lot about cloud computing too. Our applications are all living in the cloud now, right? The applications themselves and the databases. So the advantage that cloud computing has for companies is they no longer have to manage the servers. So in the old days, you would have a web server, you'd have a database server, and all live in your company in the computer room, and you had to back it up and you had to maintain it, you had to upgrade it. So now you just pay Microsoft or IBM or Amazon, and they do all that for you. You just click a button, your program or database goes up there, and you don't worry about all that management. They do it for you. So it's kind of nice. It costs money, but it saves you money in other places. So the Microsoft Intermediate Language and Common Language Runtime, this is all stuff that kind of happens in the background. So when you create that executable file, when you're done with your program, you click run, it goes and it creates an executable file. But in the background, it's doing a little more than just creating a file. So when you click that button, it creates a set of electronic code expressed in intermediate language called Microsoft Intermediate Language, or MSIL. When the program is executed, a portion of the .NET framework called the Common Language Runtime reads the MSIL and causes the instructions within the program to be executed. Like I said, this all happens in the background. You don't even know what's happening, but it's kind of nice to know exactly what the terminology is. You'll never have to worry about it, hopefully, but terminology is there. So what types of applications can you create with Visual Basic? So classic Windows desktop applications. They run on a computer or other device. Windows Universal applications. Windows is trying to, or Microsoft is trying to make Visual Studio, Visual Basic like Java. The advantage that Java has over Visual Basic and C# is a Java program, you can create it once and it'll run on Windows. It will run on a Mac. It'll run on Linux. Windows programs, VB programs, only run on Windows computers. Now, this with Windows Universal apps, they're trying to change that, but it's not there yet. We can create web applications using ASP.NET and we can create database applications using ADO.NET. And you can do a combination of those. You can write an ASP.NET application that also uses ADO.NET to connect to a database, or a Windows application that uses ADO.NET. Often you will do that. You will have Windows or web applications to connect to a database. Something new with Visual Studio 2017, and you guys probably know a whole lot more about this than I do, is Microsoft HoloLens. So this is Visual Studio work with Unity to build HoloLens apps and test them on a HoloLens emulator. Apparently the emulator uses Hyper-V virtual machine to run the app. HoloLens are stimulated using your keyboard, mouse, or Xbox controller. So I guess it's kind of like a augmented reality goggles that you put on. I've never used one. Maybe we can talk about this a little bit in class when you guys are back in here. I'm assuming we can build some applications with it. Might be something cool to play around with. This is what I guess the emulator looks like. I guess you can have your program just kind of floating around in the classroom, which is kind of cool. We've actually built some augmented reality apps for Apple last year, and some of you will probably have an opportunity to continue working on those this year. So if this is something you're interested in, if you crank through all your VB stuff and your C# stuff, we'll have some opportunity to work on some cool stuff like that. Just a summary of this chapter. Trying to understand the fundamentals of computer programming, understand the difference between Visual Studio and Visual Basic, and in subsequent chapters, you're going to learn how to use Visual Studio and VB 2017 to create Windows Classic desktop applications, database applications, and mobile applications. And that is all I have.